This balanced equation is very important because if we go through a chemical reaction, we have to have the same mass on the left side of the arrow as we do on the right, or the same number of atoms. Otherwise, we would just lose or gain atoms into nowhere. So this would violate the law of conservation of mass. So an important aspect of chemical equations that you will be tested on is balancing them, making sure what is on the left equals what is on the right. So let's go through some examples about how we do this, how we balance a chemical equation. So here, let's look at this first example, where we have zinc reacting with HCl to produce zinc chloride plus H2. We're ignoring the phases here for simplicity. So what we can see is we have our reactants and products written out for us. But what we can notice is if it's balanced or not. We see we have one zinc on the left and one on the right side of the arrow, so that's balanced. But we can see we have one H on the left in HCl, but two on the right, and then we only have one Cl on the left, but two on the right as well. So it's unbalanced. So how we balance a chemical equation is by adjusting the coefficients in front of the species. So here, if we see that if we put a 2 right here in front of HCl, then we have 2 hydrogens on the left, which balances the hydrogens on the right, which is also 2. Then notice that we have 2 Cl on the left, and then we have 2 Cl on the right. So we just so happened to also balance the chlorine on the left and the right. Some rules to balancing is that we can only adjust the coefficients. We can't adjust subscripts on the molecules, because if we change a subscript, then it makes it a different molecule and it's not the same chemical reaction. Another rule is that when we put coefficients in front of each of the species, what we have to do is make sure that they are 1, whole numbers, and 2, they are the lowest possible whole numbers for that reaction. For instance, in the top example here, we couldn't have 4, 4, 4, and 2 here because it isn't the lowest whole number coefficients that we can have. The lowest we can have is what is shown here. And we couldn't have 5 halves, 5 halves, 5 halves, and 5 fourths, say, because those are fractions, they are not whole numbers. Let's look at a more complex example. A good tip for solving and balancing one of these chemical equations is to start with a simpler element.